I'm Anil Kumar, and in this video we'll discuss basic concepts about trigonometry. And we'll consider right triangle trigonometry. So we'll consider a triangle which is a right triangle. Let us say this is our triangle ABC, where the sides are shown as vertices are capital ABC. The sides will be, the side opposite to A will be referred to as small a side opposite to B as small b, opposite to C as small c. In trigonometry, we talk about ratios of sides as one trigonometric identity or a trigonometric ratio. Now, we have terms like sine A, cosine A, and tan A. Now, these are three primary trigonometric ratios. So, we call them primary trigonometric ratios, right? So, let me write this here as primary ratios. Trig ratios, correct. So these are our primary trigonometric ratios. In a given triangle, what is sine A, what is cosine A, what is tan A? We can know that from a simple rule which we learn saying SOHCAHTOA. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tan is opposite over adjacent side. Now if I am looking from the side A, angle A for example, when I say sine A, then we are referring to this vertex and that angle A. So sine A will be opposite side. So from A, this side is opposite, right? And here we have hypotenuse. So sine A will be opposite over hypotenuse. So it could be written as BC over AB, right? So I could write this as opposite over hypotenuse, which in this particular case is BC over AB, correct? Similarly, I can write cos A. Cos is adjacent side over hypotenuse. Adjacent means adjacent to the angle and 90 degrees. So this is adjacent side, right? So I'll write ADJ. So it could be written as A adjacent side, let me write first, over hypotenuse, and that is equals to AC over the hypotenuse AB, right? Tan A is opposite over adjacent. So opposite to angle A is BC. So we'll write this first, opposite over adjacent side. In our case, tan A will be BC over AC. So that is the first thing you learn, that with respect to any particular angle, we can find the value of trigonometric ratios. Now, what you also learn about this is that hypotenuse is the longest side. Therefore, the value of sine and cosine can be maximum 1, right? So sine and cosine is maximum 1, right? This is also maximum 1, but this ratio could be anything, correct? So the ratio tan A could have any real value. So I'll say any real number, right? So maximum value is 1 for sine or cosine. Now when will sine be maximum? Sine is maximum when the opposite side is as close to hypotenuse, right? So if I move from here, increase the angle, as I increase the angle, the value of sine increases since the opposite side length increases. When this angle becomes 90 degrees, then both sides are same. So we know that sine of 90 degrees is equals to 1. That is the maximum value. And we also know that sine 0 is 0. When I have 0 degrees, then the height is 0. As far as cosine is concerned, maximum value of cosine is when our triangle is flat, 0 degrees. In that case, adjacent side is same as hypotenuse, correct? So we know that cos of 0 degrees is 1. However, cos of 90 degrees is equals to 0. Since then, the adjacent side will be 0. And in general, tan of A will be equals to ratio of sine of A over cosine of A. So the ratio of these two will give you tan of A. We'll also prove why it is so in this particular example. Let's begin by saying tan A equals to opposite over adjacent, correct? Now, if I divide both by hypotenuse, then what happens? Then what I get in the numerator is opposite over hypotenuse, and opposite over hypotenuse is sine A, right? So I get sine A divided by adjacent over hypotenuse, which is cosine A. So this is a good way of proving that tan A is sine A over cos A, right? So this is one way. Second exercise which we like to introduce here is that in a right triangle, what is a square plus b square equals to? It is a right triangle, Pythagorean theorem, a square plus b square is c square, right? Now if I divide everything by c square, what do I get? If I divide everything by c square, I get a over c whole square plus b over c whole square equals to 1. A over c is what? A is opposite, c is hypotenuse. Sine A, right? So we get sine square A square plus adjacent over hypotenuse is cos square, right? Square A equals to 1. Also note how should we write sine square A and cos square A. Sine, cosine are lowercase and square is written like this, sine square A, and that's an identity. Sine square A plus cos square is always 1. So this is all we can know about trigonometry of right triangles. Now other important things which you learn is how to solve a triangle, right? So now we will see how to solve a triangle, right? Especially we'll begin with right triangle, and let me take one more example here. So let's say we have a triangle here and I am given one angle and one side. So if I am given a side angle, let us say this is 30 degrees, and one side, if I am given the side opposite, let us say this side is 6, and I need to find other angles, and we know this is right triangle. How can I find the other sides? I can use the trigonometric ratios to find the other sides. Let us see how. Now this example, since we know the opposite side, and to find hypotenuse, opposite hypotenuse, we should use sine. So here we will say sine of angle given, which is 30 degrees, is equals to 6 over, let me write this side as c and this side as a, okay? So sine of 30 degrees will be opposite over hypotenuse, which is 6 over c. From here we can find what c is. So c is equals to 6 divided by sine of 30 degrees. We can use a calculator to find the answer. Setting should be in degrees. 6 divided by sine of 30, bracket close, equals to 12. So that gives hypotenuse of 12. To find a, we could use Pythagorean theorem or we can use tan ratio. So I'll use tan ratio for the time being. So tan 30 degrees is 6 over a, right? 6 over a. So a is equal to 6 divided by tan of 30 degrees, correct? So we can again use the calculator and find our answer. 6 divided by tan of 30 degrees is equal to 6 square root 3, right? So that is how you can get exact value of the missing side, right? Now here in the space between, I like to use this space to show you. If we are given sine of a ratio, how to find theta? That is also an exercise which we learned during grade 9. So the question here is, if I know that sine of angle theta is equals to 0.2456, how to find theta? To find theta, we have to find sine inverse using calculator of 0.2456. So how to use it? Sine inverse is normally the shift operation. Sine inverse, you can see it. So you can now type in 0.2456 within brackets equals to 14.21. So we get theta as 14.21 degrees, which you can round to 14.2 degrees. So that is also a way, that is the way to find the angle once you know the ratio, correct? So you can find the ratio from the angle. So I hope from here you get a fairly good idea about how to solve your triangles if you are given the angles, right? And if you are given a side. And also how to find the ratio of the side when you are given the value of the trigonometric ratio, right? Now, this is the last exercise. How do you find, if I give you that sine theta is 7/9, how to find what is cos theta equals to? Now, this is a huge exercise. How are you going to do it? So what we learned here is that when I say sine theta is 7/9, I can actually draw a right triangle, and I can say that let this be the angle theta. 7 is opposite side, 9 is the hypotenuse. Now from there I can find the third side. Third side is 9 square minus 7 square square root, and I can use Pythagorean theorem to solve it. This is one way of doing it. However, I will use another method, and of course cos theta from here will be equals to this square. Let me calculate this for you. So we have square root, and we have 9 square minus 7 square equals to 4 square root 2, right? So this side is 4 square root 2, and therefore cosine theta is 4 square root 2/9. The ratio of these two sides, we get our answer. The alternate way is, we know sine theta is 7/9, we can find the angle theta. You say theta is sine inverse of 7/9. So we'll do shift sine inverse of 7 divided by 9 bracket close equals to, we get the angle 5.51.0575. Now once we know the angle, we can find cosine and the side. Now cosine theta is equals to this particular side, which is adjacent side, let me say adjacent side, over hypotenuse, right? Over hypotenuse, correct? So in our case, adjacent side will be equals to cosine of theta times hypotenuse, right? So we get adjacent side equals to hypotenuse, which is 9. Okay, let me push the page a bit, right? So, and do it here. So from here we can say that the adjacent side, let me write here, adjacent side equals to 9 times cos of theta. And for us, theta is how much? 51.057. 9 times cos of 51.0575. Let's use calculator to find the angle. I already have the angle, so I'll say cos of the answer, right? And times 9 equals to, we get 5.65. Answer was 4 square root 2. The side length we found was 4 square root 2 using Pythagorean theorem, right? Let us see what is 4 square root 2 in decimals. Does it match? Okay. So we have square root 2, let's say square root 2 times 4, let's do it again. So we have 4 square root 2 equals to, in decimals, it is 5.65. Exactly the same value, correct? So that way also you can find the third side using sine and cosine in a different way. So you could use at times in a right triangle Pythagorean theorem, or you can use the ratios in different ways to find. You could also use the formula which we learned, which is sine square a plus cos square a equals to 1, to solve such cases. Well, the easiest way, of course, is once you know sine theta is 7/9, find the third side using Pythagorean theorem, and then you know the answer. So that is probably the best way of solving this question. I hope that helps you to understand few concepts of trigonometry in this particular video. In part 2, we'll discuss a bit more about it. Thank you and all the best.